Welcome to Stranger's Clubhouse. I am your host, Dragonborn, and in this episode, I'm actually going to be It was a question I got from my father, which is the best I've gotten as far as questions. So, anyway, basically, his question was, he had questions about dark matter and gravitational anomalies. So I'm going to start with dark matter. So the main logic behind the existence of dark matter goes like this: all the matter that we see, that we experience, all the matter that we can see in the universe, all the energy. The idea is that, and calculations by scientists have confirmed this, that less than 5% of the entire universe, or rather that everything that we can see, all the energy we can detect, only makes up for less than 5% of the observable universe. So the idea is 26%, which basically equates to that we only make up for about 20% of the mass in the universe. So where is the other mass? I'm not going to get into the exact details. There's if you just look up dark matter, you can find plenty of other sources that get into more details, but basically, the idea is that there are these dark matter nets, and these dark matter nets are what allow galaxies to form. And when it comes to dark matter itself, it's supposed to be undetectable with electromagnetism. So it doesn't absorb or emit light; it just passes through. So, kind of difficult to detect. We know that there's something there, though, because we can detect it via gravitational lensing. It's basically when light bends around things with a large amounts of mass. And when it comes to the missing mass, this was first found to only be able to. The universe could only really exist as we know it exists via dark matter, because, as I mentioned, only 20% of all the mass in the universe is accounted for with visible matter. So, that would mean that all the stars in the outer rim of the galaxy should be flying away, like when you're shaking a piece of something with powder on it, and you shake it and the powder flies off. That's what the stars should be doing, but there's something gluing the stars to the galaxies, thus allowing the galaxies to stay together. And this is dark matter. So I'm kind of recording this just at random, so forgive me if it isn't as professional or whatever fancy as mine normally are, but this is just, again, I just wanted to do this. But if you're wondering why I haven't uploaded in a while, I didn't do my homework as I should have, and I got my phone taken away, but I'm allowed to. But I have my phone briefly back, so so I can actually record another episode. So what is this dark matter? There are some theories. The most popular one is the one with the dorkiest name. Basically, the idea is that there are particles that don't interact with electromagnetism, that don't even interact with themselves that much, other than gravitationally. So much so that they are called weakly interacting massive particles, or yes, the name equates to WIMPs. It's a bunch of WIMPs holding the universe together. Well, that's the most popular thing, but there are some others, but there are way too many to get into here. So, although the only things we only know 3 things for sure: that dark matter exists, that we can't detect it via electromagnetism, and that we need to do more research as to find out what this stuff is that holds the universe together. That's the 3rd thing. It's kind of vague, but that kind of resembles the nature of dark matter, as far as we know now. I mean, some 100 years in the future, we'll probably be able to answer that very well. So, dark matter, it makes up 80% of the mass of the universe. Of course, as I said, it was only 26% of the universe, so that would only equal 30%. So, what's the other 70%? The other 70% would be considered, it's called dark energy, because again, we don't really know what it is. But we have a couple more theories on this, but we know even less about it than dark matter, leaving us with only theories. One theory is that the quantum foam, which I talked about on an earlier episode, is causing space to expand. Well, I should probably explain dark energy first. Basically, what dark energy is it is a cosmic, is essentially the energy of empty space, which I actually did get into, like the vacuum energy. Well, it's unknown what dark energy really is, but that's one of the most prevalent theories on it. Another idea is that empty space that's not an actual energy, it's just an intrinsic property of empty space itself. Where what dark energy does is, we've noticed, well, I mean other science, like astrophysicists have noticed that the further they look out, the faster the galaxies are running away, you could say, away from us. And in order to explain this, we had to accept that space itself was expanding. In fact, space itself could expand faster than the speed of light.